A very good day I bid to my lecturer, Miss Chandrika, and my fellow friends. So, my name is Luciano Avery de Costa, and I'm from Group 21. So, today I'll be doing a presentation for my assignment. So, my group members are Lim Si Yuan Shane, James Ong Yu Hao, and Marcel Han. Okay, so the topic we have selected for today is non-preemptive priority and preemptive SJF. So, our question for non-preemptive priority and preemptive SJF is this, whereby we have five processes, which is whereby the first process has an arrival time of 0, and then a burst time of 11, and a priority of 2. The second process, which has an arrival time of 5, a burst time of 28, and a priority of 0. And the third process, which has an arrival of 12, burst time of 2, and a priority of 3. The next process, which is process 4, 2, 10, and 1, respectively, and 5, 9, 16, and 4. So for the first question, which is non-preemptive priority. So the first thing that we are going to do is rearrange them according to their arrival time. So for the first process, which is which has the earliest arrival time, is P1, and then continuing on, we have P4, which has the arrival time of 2, and the next one continuing on, which has an arrival time of 5, is P2, and then P5, which has an arrival time of 9, and then the last one, P3, which has an arrival time of 12. So we continue off with the Gantt chart. Okay, since this is a priority, we have to focus on with the priority. But since it's a non-preemptive priority, so the starting of the Gantt chart, we have to focus on the arrival time. Okay, the arrival time. So the earliest arrival time that we have is P1, which has an arrival time of 0. Then we add on the arrival time, the start time of 0 with the burst time of P1, which is 11. Okay, then next on continuing, we have to focus on with the priority. Uh, the earliest priority that we have is P2. Okay, so what we do next is add on the 11 right here. We add on with the burst time of P2, which is 28. Therefore, you get 39. So continuing off, the next priority that we have is 1, which is P4. Okay, so therefore, we add this 39 here with the burst time of P4, which is 10, which is equals to 49. Then continuing on is usually P1, but since we have already done P1 right over here, we cannot redo it all over again. So we continue off, so we cancel out P1 right here. So continuing off in the next one, which is P3. Okay, so therefore, then we add the time of 49 right here with the burst time of 2. So therefore, we get 51. And for the last one, which is P5. So therefore, we add 51 right here, 51 right here, with the burst time of P5, which is 16. Therefore, we get 67. Okay, so next up, once we have already done the Gantt chart and done the Gantt chart, so next we have to do is the waiting time. Okay, so what we have to do first is calculate the waiting time for each process. So the first process that we have is process 1. Since it has the earliest arrival time of 0, so we have to calculate from the start time. So the start time of P1 is 0. So 0. And then we have to minus it off with the arrival time of process 1. So the arrival time for process 1 is 0. Therefore, P1 is equals to 0 minus 0, which is equals to 0 milliseconds. The next part is P2, which has the start time of 11. Okay. Then we minus it off with the arrival time of P2, which is 5. Okay. Therefore, we get 11 minus 5 is equals to 6 milliseconds. For the third process, which is P3, we have the start time of 49. Then we minus it off with the arrival time of P3, which is 12. Therefore, we get 37 milliseconds. For the fourth process, we have the start time of 39. Then we minus it off with the arrival time of P4, which is 2. Therefore, we get 37 milliseconds. And for the last one, P5, we have the start time of 51. Okay. Then we minus it off with the arrival time of P5, which is equals to 9. Therefore, we get 42 milliseconds. Okay. So now we have all of the waiting time right here. Okay. Now we have to calculate the average waiting time. To calculate the average waiting time, we have to add on all the 5 processes of the waiting time for all 5 processes. So for P1, which is 0, plus P2, 6 milliseconds, plus P3, 37 milliseconds, P4, 37 milliseconds, and P5, 42. And then we have to divide it by 5. Why 5? Because we have 5 processes right here. So divided by 5. Therefore, when you add it all up and you divide it by 5, you get 24.4 milliseconds. Okay, so next up, continuing on, is preemptive SJF. So the same thing as the non-preemptive priority, what we have to do is uh, order it by arrival time. So starting off with the earliest arrival time, which is P1, with the arrival time of 0. Next up, P4 with the arrival time of 2, P2 with the arrival time of 5, P5 with the arrival time of 9, and P3 with the arrival time of 12. So next up, we continue on with the Gantt chart. So P1 first arrives at time 0 with a burst time of 11. Yeah. So since this is the only process in the system, P1 will start executing first. Okay. Then at time 2, which normally P4 arrives with a burst time of 10. But since we compare it with P1, which has a remainder of 9 since 2 units have already been executed, therefore P1 executes all over again. So then, at, so then we continue on with the next arrival time, which is uh, P2. Okay, so P2 arrives with a burst time of 28. But then we compare it with P1, which has a remainder of 6. Then therefore, since P1 has the shortest remaining burst time, it continues to run. And then next up at time 9, which P5 is supposed to execute. Then we compare with the remaining burst time of P1, P4, and P2, which is 2, 10, and 28 respectively. Therefore, P1 is still the shortest remaining burst time. Therefore, it executes all over again and gets the next time, which is 11. So now that P1 has already finished, the processes the system looks at the remaining processes, which is P4, P2, and P5 with burst times of 10, 28, and 16 exactly. Therefore, P4 has the shortest burst time, so it starts executing at time 11. So for the next part, at time 12, P3 arrives. So then we compare with the remaining burst time of P4, P2, P5, and P3, which is 9, 28, 16, and 2. So therefore, since P3 has the shortest burst time of 2, P3 starts executing. And the next part, which is time 14, P3 already finishes execution since his burst time was only at 2. So now the system chooses the next process with the shortest remaining burst time. The remaining processes are P4, P2, and P5. So therefore, P4 has the shortest remaining burst time, which is 9. So therefore, it resumes its execution all over again. And then next up, since P4 has finished executing, So the system chooses the next time, which is from P2 and P5, 28 and 16 respectively. Therefore, P5 has the shortest burst time. Therefore, it starts executing. Okay. And for the last part, uh, since P5 has finished executing, the remaining process is only 28. Is only P2. Therefore, it starts executing. So, with a burst time of 28, therefore 28 plus 39 equals to 67. Okay. So continuing on, the next part we have to find is the waiting time. So we have to find the waiting time for each processes. So we start off with process 1. Okay. Process 1, the earliest start time is 0. So therefore, we minus it off with the arrival time of P1, which is 0. Therefore, we get 0 milliseconds. So for P2, okay, which has a starting time of 39, so we minus it off with the arrival time of P2, which is 5. Therefore, we get 34 milliseconds. For P3, uh, we have the start time of 12, and then we minus it off with the arrival time of P3, which is 12. So we get 0 milliseconds. For P4, however, since there is two start times, 11 and 14 respectively, so we calculate the first one first. So you have to calculate both of these two and add it up together. So we start off with the start time of P4, which is 11. Okay. Then we add it, and then we minus it off with the arrival time of P4, which is 2. Okay. Then next up, we add it up with the start time of the next P4, which is 14. And then we minus it off with the ending time of the last P4, which is 12. Therefore, we get 11 milliseconds altogether. Then for P5, which has a start time of 23, and then we minus it off with its arrival time of 9. Therefore, we get 14 milliseconds. Okay. So continuing on, now we have to find the average waiting time for the whole 5 processes. So as same as the non-preemptive priority, what we have to do is add up all the 5 processes waiting time, which is 0 plus 34 plus 0 plus 11 plus 14 milliseconds. So we divide it by 5, because it has 5 processes. Therefore, we add it up all together and we divide it by 5, which is equivalent to 11.8 milliseconds. And that's our final answer. Alright, and that's all from my video presentation. I would like to thank my respective lecturer, Miss Chandrika, for guiding us throughout this entire project and guiding us. I would like to also thank my fellow members for helping out in this presentation and doing the slides. Thank you.